Welcome to my channel Tour Rational. I'm Pranay Sharma, and in this video we are going to see the solutions of CS1 Paper A conducted by IFoA Institute in April 2022. We'll go through the detailed solutions, but if you want the solution sheets, I will leave a number below in the description where you should WhatsApp or Telegram your email ID so that we can email you the answer sheets. Do like, share and subscribe and check out other videos on my channel. And let's get started. Question number 1. The number of emails X to be replied in a day by an employee of a customer service center of an insurance company is modeled as a Poisson random variable with mean 25. The time in minutes Y that the employee takes to reply to X emails is modeled as a random variable with the conditional mean and variance given by this. Calculate the unconditional variance of the time Y that the employee takes to reply to emails in a day. So we'll say our X follows Poisson 25, expected value and variance would be same, that is 25. And we'll have our variance of Y, that is our unconditional variance of Y formula, expected value of variance of Y given X plus variance of expected value of Y given X, that gives us this. And this would be expected value of X plus 9, and here the constant added or subtracted does not make any difference, and whatever constant was multiplied will be squared. So the value we get is 259. Let's see question number 2. Question number 2. The number of claims arriving at an insurance company is assumed to follow a Poisson process with rate m is equals to 2 per year. State the distribution of the random variable n1. And second, calculate the probability of more than 2 claims arriving in year 2 given that 5 claims arrived in year 1. So we'll say NT would follow Poisson 2T, where N1 will be nothing but Poisson 2. This is every year. Then for the second one, we are saying that we are calculating probability of N2 minus N1. That means we are only taking the second year into account. This would be 0 to 2 years. This would be 0 to 1 year. Should be greater than 2 given that N1 is equals to 5. This is one way of writing. You can directly say that each year they are independent of each other. Therefore, this will be directly equal to probability n greater than 2, and that would be 1 minus 0, 1 and 2. That gives us 0.323324. Third part, calculate the probability of more than 2 claims arriving in year 2 given that no claims arrive in year 1. So it's exactly the same. So the difference is in the first year, last time we said we have 5 claims, now we have 0 claims, but it should not make any difference when we are calculating probability that we will have n greater than 2 in year 2. So probability remains exactly same. In fourth part, they are saying compare the results in part 2 and part 3. So we'll say because the number of events in the time interval is independent of the number of events up to the start of that time interval, and the number of events in a time interval of length r does not depend on whether the time interval starts, the two probabilities are same. How many number of events have already occurred before the time interval starts does not make a difference, and which time interval we are talking about, that also does not make a difference. Therefore, the probabilities are exactly same. For the fifth part, identify the distribution of the time of the nth claim justifying your answer. So we'll say waiting time between 2 Poisson process event is an exponential distribution with the same rate. So Ti follows exponential m. The inter-event time is independent of the absolute time. Hence, the distribution of the time of the nth claim will be addition of all such times. So that would be gamma n comma m. Sixth part, calculate a random value from the exponential distribution with parameter m is equals to 2 using a realized value of 0.201 from uniform 0,1 distribution and the inverse transformation method. This can be done in 2 ways. I have shown both of them. We can say either f of x is equals to f of u, and that gives us this. Rearrange it and you will get x is equals to 0.112197 Or you can say that your f of x is equal to f of 1 minus u, and you will get the answer as 0.802225. Both of these answers will be accepted. Let's go to the next question. Question number 3. Let x and y be two continuous random variables jointly distributed with the probability density function. Identify which one of the following options gives the correct expression for the marginal density function of x, and for the second part, identify which one of the following option gives the correct expression for the marginal density function of y. As these were MCQ style question, they are only expecting you to write the answers, but I have shown the expression here as well, how we would calculate it. For marginal density, we will integrate our joint distribution with respect to y to get marginal density of x. So we get 2 e raised to minus 2x. That would be that x is following an exponential distribution with parameter 2. For y, we'll do the same thing. We'll integrate with respect to x, and we'll get 3 e raised to minus 3y. That gives us y follows an exponential distribution with parameter 3. Third part, comment on whether x and y are independent by using your result in part 1 and 2. And fourth part, calculate the conditional expected value of y given x is greater than 2. So we can say our f of x into f of y would give us our joint density, hence x and y are independent. And for the fourth part, as x and y are independent, this should not matter, and we'll get expected value of y given x greater than 2 should be equal to expected value of y. That would be 1 by 3, because I have already said it is an exponential distribution. You can specify it here as well. Last part, identify which one of the following option gives the correct expression for probability x greater than y. Here we will have to take our conditional probabilities. So we'll say probability x greater than y must be such that I will take a specific value of y and integrate all such possible values. So I'll say probability x greater than y such that y is equals to y, and for all different values of y we'll get this joint distribution where our y is going from 0 to infinity but x is going from y to infinity. Either you can integrate your joint distribution or integrate the independent f of x, f of y separately, does not matter, you'll get the same answer as 3 by 5. That is our option B. Let's go to the next question. Describe what is meant by each of the following: a random sample and a statistic. So a set of items selected from a parent population is a random sample if the probability that any item in the population is included in the sample is proportional to its frequency in the parent population, and the inclusion exclusion of any item in the sample operates independently of the inclusion exclusion of any other item. I have directly taken this from the book. You should write it in your own words. B part, a statistic is a function of sample value and known parameters which is used to infer about the unknown parameters using sampling distribution. Next, a new political party is interested in the level of support it would have among the voters in a particular country. The random variable x is defined as x equal to 1 or 0 if the voter would support the party, otherwise okay. A random sample of 50 voters are presented with a sample summary of the party's policies and asked if they would support the new party. The random sample is represented by x1 to x50. Second A, identify a suitable population together with a possible parameter of interest. And B part, determine using your answer to part 2a the sampling distribution of the statistics y is equals to summation of xi. We'll say let the proportion of voters that would support the party B be P such that x follows Bernoulli P. And for the statistics we'll say y, that is summation of x, would follow nothing but a binomial distribution 50 comma P. Let's see the next question. Question number 5. Let x1 to xn be independent, identically distributed random variables following a Poisson-M distribution. Suppose that rather than observing the random variable precisely, only the event x equal to 0 or x greater than 0 are observed for I 1 to n. Let y be the random variable with y either being 0 or 1 when x is 0 or x is greater than 0. Explain why the distribution of yi is a Bernoulli P distribution with the parameter p is equals to 1 minus e raised to minus m. So we'll say x follows Poisson-M, we'll calculate probability x is equals to 0, probability x greater than 0. So y is a discrete random variable with the possible values 0, 1 and the probability of success, that is R1, as 1 minus e raised to minus m. I have written it as p, so I can write here Bernoulli P. Second, identify which one of the following expression gives the correct likelihood function based on the observation y1 to yn in terms of y bar is equals to 1 by n summation yi and the unknown parameter m. So as we have n samples from Bernoulli distribution, we'll multiply each one of their probabilities. So probability that y will be equal to 1, we have yi values, and y equal to 0, we have 1 minus yi values. So we'll get 1 minus e raised to minus m raised to summation y and e raised to minus m raised to n minus summation y. So writing them in terms of y bar, we'll get these values. The option is C. Third part, derive an expression for the maximum likelihood estimate m hat of m in terms of y bar. And fourth part, state the condition that m hat and Lm must satisfy for m hat to maximize the likelihood function. So we'll take the log of the likelihood function, differentiate it and then equate it to 0. Rearranging, we'll get our m hat will be equal to log of 1 minus y bar. And we'll say the double differentiation of the log likelihood should be less than 0 at m is equals to m hat to maximize the likelihood function. It is just 1 mark question, so we don't have to actually show it. Let's go to the next question. Question number 6. The size of claims on a certain type of motor insurance policy are modeled as a random variable x with the probability density function given to us. First, identify which one of the following expression gives the correct log likelihood function in terms of the random sample x1 to xn and the unknown parameter alpha and beta. In the second part, they are saying derive the MLE of alpha hat of the parameter alpha as the function of the parameter beta for the random sample x1 to xn. So first we'll write down our likelihood function. That gives us alpha raised to n, beta raised to alpha n upon summation of this xi raised to alpha plus 1. Taking log, we'll get n log alpha plus n alpha log beta minus alpha plus 1 and pi will become summation of log xi. So the option is D. Then we will differentiate log likelihood, equate it to 0. Rearrange to get our alpha hat would be 1 by y bar minus log of beta, or you can write it in this term, that would be n upon summation of log xi minus n times log beta. I have even specified here what my y bar is going to be. I'll say y bar should be equal to summation of log xi by n. Third part, comment on the behavior of the PDF of x when beta increases. So we'll say as beta increases, the minimum value of x increases, hence the overall possible value of size of claim increases. Beta is directly proportional to the PDF of x, but also results in relatively higher value of x. Therefore, as beta increases, overall PDF of x stays relatively similar for a different range of x. Also for a specific value of x, PDF of x increases as beta increases. I think they were expecting only the last line. You can explain all the relationships or you can just write the last line. Fourth part, determine the MLE beta hat of the parameter beta based on your comment in part 3. As the likelihood is directly proportional to the beta, we'll say the likelihood will be maximized when beta is maximized. So therefore beta hat would be max of beta, that would be minimum value of the sample of X. Next, the value of a sample of 10 claims are given in the table below. Calculate the mean and the standard deviation of the natural logarithm of the sample. So we will take log of each of these values and then calculate the mean and the standard deviation. Calculate the MLEs alpha hat and beta hat based on the sample. So here I have calculated the log of each of these values. Accordingly calculated the summation y and summation y square value and y bar and the standard deviation of y. So beta hat was minimum of the sample of X, minimum turns out to be 5000, and then substitute that for the alpha hat, we'll have y bar as well as log of beta, that gives us 1.00381. Let's go to the next question. Question number 7, the probability density function of a gamma distribution is parameterized as follows. This density can be expressed in the form of exponential family as follows, where the exponential family notation is the same as that in the actual formula table book. First part, justify that mu and sigma square are the mean and the variance of the distribution respectively using the properties of the exponential family. So we'll say our expected value must be b dash theta and we'll differentiate to get mu. And similarly b double dash theta would be 1 by theta square, that is mu square. So variance is b double dash theta into a phi and we get sigma square. And actually is modeling the relationship between claim size and the time spent processing the claim called the operational time OPT. A statistician suggests using a model with the claim size being the response variable following the gamma distribution given above. Comment on why a gamma distribution may be more suitable than the normal distribution for the claim size. So we'll say the claim size will be a continuous random variable with the range from 0 to infinity, which will mostly be positively skewed. Hence the gamma distribution may be more suitable than the normal distribution. They actually decided to fit a generalized linear model with a gamma family and obtained the following estimates. So we have parameter and the standard deviation. Explain using the model output shown above whether the variable OPT is significant or not. So this can be done in many different ways, where you can take the confidence interval and figure out whether 0 lies between that or not. You can do the hypothesis testing to figure out whether the value can be equal to 0 or not. Or you can do an approximation where you will say that the estimated value, mod of the estimated value, is whether greater than 2 times the standard deviation or not. Usually we take approximately 2, it should be 1.96, so you can take 1.96 or you can take 2, both works, or you can do confidence interval or hypothesis testing. Here I have used the hypothesis testing, and we are saying the test statistic would be nothing but the estimated value divided by the standard deviation, that would be 20.554. The p-value is very small. Hence the variable OTP is very significant or is significant. Another statistician has suggested that an alternative model needs to take into account the legal representation variable, which shows whether or not an insured person had legal representation. Explain the difference between the variable OPT and the legal representation in a statistical sense in the context of a GLM. So we'll say the variable OPT is a numerical variable with the range of 0 to infinity with 2 parameters, that is the intercept parameter and the slope parameter, that are assumed to be constant irrespective of the values of OPT. And the variable legal representation is a non-numerical factor with 2 possible values, yes or no, with 2 parameters that are dependent on the values of the variable. Then we have the actuary now has to choose between the following two models for the claim size. We have model 1, only OPT is used as a covariate, and model 2, both OPT and legal representation are used as covariates. So an analysis of variance was carried out to assess the significance of the covariates, OPT and the legal representation denoted by LR. The result obtained are given below, where claim size is denoted by CS. So we are seeing our model 1, model 2 analysis done. We can directly look at the p-value. P-value is very small. So we have determined which model provides the better fit of the data. So we'll say as the p-value is very small, we have sufficient evidence to reject H0, hence model 2 provides the better fit to the data. Let's go to the next question. Question number 8. The time t until the next lorry arrives at a customs checkpoint at the border of a country is modeled with an exponential distribution, that is, t follows exponential lambda, where lambda is the unknown parameter. The time is measured in minutes. Identify which one of the following expression gives the correct likelihood function for the parameter lambda based on the sample observed time until the next lorry arrives, ti 1 to n. So likelihood function would be pi lambda e raised to minus lambda I. So that gives us lambda raised to n e raised to minus lambda summation ti. That is option 1 or option A. An analyst uses Bayesian inference to obtain an estimate for lambda. They choose a gamma distribution with the parameter alpha and beta as the prior distribution. For lambda, verify that the posterior distribution of the parameter lambda is a gamma distribution with the parameter alpha plus n and beta plus summation ti. So our prior value would be proportional to lambda raised to alpha minus 1 e raised to minus beta lambda, and we already have the likelihood here. We'll multiply both of them and we'll get lambda raised to alpha plus n minus 1 and e raised to minus of lambda into beta plus summation ti. So we'll say by uniqueness property, our posterior value of lambda would follow a gamma distribution with alpha plus n comma beta plus summation ti. For the third point, they are saying assume that a total of 20 lorries have arrived at the checkpoint. I am assuming they are missing a small statement here. It should say in 60 minutes or something like that. We'll talk about that later. Determine the Bayesian estimator for lambda in terms of the parameters alpha and beta under the quadratic laws based on this sample. So under quadratic laws, we know it is going to be the mean of the posterior distribution. Therefore, we get alpha plus 20 upon beta plus summation ti, or you can write here 60 as well. Fourth part, explain how to determine the Bayesian estimator for lambda under all or nothing loss based on this sample. Fifth part, identify which one of the following option gives the correct Bayesian estimator for lambda under all or nothing loss based on the sample given. Because here in each one of them, you can see in the denominator we have 60 where it should be summation ti. So that is why I'm assuming that it is talking about 60 minutes. And for the last one, they're saying comment on the difference between the two estimators in part 3 and 5. So we'll say under all or nothing, the estimate is the mode of the posterior distribution. As the mode is the maxima of the PDF of the distribution, we can use the following step. Take the PDF of the posterior distribution, take the log of the PDF. This is optional. You can not do this and you'll still get the same answer. Differentiate the log of the PDF with respect to the variable. By equating to 0, find the possible values of the variable. To check the maxima, double differentiate the log of the PDF and substitute the values obtained in the previous step. And last part, if the second derivative is less than 0, then the substituted value is maxima. In the next one, we have to select the correct option of the mode of this distribution. I have shown you here how we would have calculated the mode. We don't have to show any of this. This is just a MCQ. We just have to write the option, that is B. For the comment, the two estimators are nearly the same with the estimate of quadratic error loss will always be larger than the all or nothing, and the difference decreases as the sample size increases. Let's go to the next question. Question number 9. Consider the linear regression model in which the response variable yi is linked to the explanatory variable xi by the following equation. Comment on whether or not the linear regression model as presented above can be used to make inference on the parameter alpha and beta. That means we are talking about whether we can estimate these values or not. So we'll say using maximum likelihood estimate method or square error loss method, the equation can be used to find the estimates of the parameter alpha and beta for a given sample. And we have the coefficient of determination for this model is given by r square, which is equals to s square by s square xy upon sxx syy. Verify that r square gives the proportion of the total variability of y explained by the linear regression model. We'll say total variance SSTOT is partitioned into variance explained by the model, that is SSREG, and the variance due to residuals, that is SSRES. As r square is equals to SSREG by SSTOT, it gives the proportion of the total variance explained by the model. I've even shown the relationship for both of them. Consider the multilinear regression model where the response variable yi is related to explanatory variable x1 to xk. Third, suggest 3 ways for assessing the fit of the multiple linear regression model to the set of the data. So 3 ways of assessing the fit of multiple regression model to the set of data are comparing r square or adjusted r square. Adjusted r square is better. We have talked about that later. We have ANOVA test of variance, and we have hypothesis test on individual covariates. A forward selection process is used for selecting explanatory variable in the multiple linear regression model. Explain whether the coefficient of determination r square can be used as a criteria for selecting variables when applying this process. So the coefficient of determination r square always increases with the increase in the number of explanatory variables. So it is not a good criteria for selecting variable, whereas the adjusted r square adjusts for the number of variables. Hence, adjusted r square is a better criteria. So for the last part, they have given us some models with some r square values as well as the adjusted r square values. We have to determine the optimum set of explanatory variable using this output. So as I said, all of the r square values will always be increasing, but for adjusted r square, we can see this is the highest value. So this model would be the most optimum set of explanatory variables. As the adjusted r square is a better criteria, the third model x1 plus x4 plus x3 is the optimal set of explanatory variable using this output. You can mention that it has the highest adjusted r square value. Let's see the next question. For the last question, a random sample of the records of a certain hospital yielded the following information on the length of hospital stay in days and the annual family income rounded to the nearest 500 of 15 discharged patients. An analyst believes that the relationship between these two variables is linear. The graph below depicts the scatter plot of the annual family income against the length of the stay and a simple linear regression line fitted by the analyst. So the summary is given and they are asking us first to comment on the relationship between the two variables. So looking at the data, you can say it is negative and it is most likely strong because all of the data is near to the line. Then second, they are saying determine the equation of the simple regression line. Third, perform an ANOVA test to determine whether the slope of the regression line is significantly different from 0. For the first, we'll comment there seems to be a strong negative relationship. As the annual family income increases, the length of stay decreases. For the second part, we will calculate our A bar value, L bar value, SAA, SLL and SAL. All of these are given on page number 24 of the table book, I believe. So accordingly calculated the beta hat as well as alpha hat values, and the regression line would be our L hat is 13.26033 minus 0.00114A. For ANOVA test, we have to calculate our SS total, that would be SLL, SS regress, that would be S square AL upon SAA, that is this much, and SS residual would be, that would be SS total minus SS regressed. So for our ANOVA table, we'll make source, degree of freedom, SS, MSS and F statistic. For regression, degree of freedom would be 1, SS we have just calculated, and MSS will just be the SS divided by the degree of freedom. Same thing with the residual, the degree of freedom would be n minus k minus 1, SS, and then MSS would be SS divided by the degree of freedom. And for total, we don't calculate MSS, and for statistic it would be MSS of regress divided by MSS of residual. And the p-value, we'll say it is upper bound test, so therefore f of 1, 13 greater than 54.27, that gives us p-value that is much less than 1%. So we'll say even at 1% level, we have sufficient evidence to reject H0, hence beta will not be equal to 0. Fourth part, calculate the Pearson's correlation coefficient between the annual family income and the length of hospital stay. And for the fifth, perform a statistical test to determine whether the Pearson's correlation coefficient for the corresponding population is significantly different from minus 0.8. As it is non-zero value, we'll have to take Fisher's Z test. So the R value would be SAL upon under root of SAA into SLL, that would be minus of 0.898195. And for the test, we'll say we are testing for rho is equal to minus 0.8 versus rho not equal to minus 0.8. For Fisher's Z test, we will calculate ZR and Z rho from, that would be the tan H inverse values of this as well as this. So the test statistic would be minus of 1.262, and the p-value accordingly 2 times probability Z greater than this turns out to be just above 20%. So it is between 20% and 30%. So we'll say even at 20% level, we have insufficient evidence to reject H0. Hence rho will be equal to minus 0.8. Last part, identify which one of the following option gives an appropriate 95% confidence interval for the Pearson's correlation coefficient for the corresponding population. So for the confidence interval, first we'll calculate the confidence interval for this Z rho. That would be our ZR plus minus Z 2.5%, that is 1.96, under root of the standard deviation, that would be 1 by n minus 3. So we'll get this, and this is also one of the options, so don't get confused. The actual confidence interval for rho is going to be tan H of this value comma tan H of this value, because we'll have to convert from the Z rho to rho. And the confidence interval would be this, that is option B. Overall, the paper was very straightforward, very conceptual and definitely lengthy. But you could very well complete it in that 3 hours 10 minutes, 3 hours 20 minutes time period. The paper was more conceptual than numerical as CS1 usually is. But overall, it was a pretty easy paper. If you find any mistakes, do write them in the comment. I will pin them so that others can see them too. Check out the other videos on my channel, but first like, share and subscribe, and I will see you in the next video.